Okay, so let's talk a little bit about sets. All right. So first idea here, what is a set? How do we describe what a set is? A set equals what? What could be a set? A group of numbers like 1, 7, and 11. That's a set, right? What else could be a set, non-mathematically speaking? A group of people could be a set, right? You guys could be a set at this table. You guys could be a set at that table. You could be a set at that table, right? So you could be set together. Right? All of us could be a set. So a set is really just a collection. It's a collection of distinct. What does that word mean? What does the word distinct mean? Unique, different, right? So that I can tell the difference in my set of what things are, right? So it's a collection of distinct, and we call the things in the sets elements. So the language that involves sets is kind of tricky. So it's a collection of distinct elements, all right? So the way that we denote that we're talking about a set is that we use these brackets, these squirrely brackets, and it's kind of hard to draw them, but here's how you do it, okay? They look like a sideways mustache to me, okay? So this is, when we have this curly bracket here, this is called set notation. So as an example, I could have, this could be my set, okay? So I have a collection of distinct elements. My elements are A, B, and C. And there happen to be a grand total of 3 elements in my set. So I could call my set, I could call this set S is equal to A, B, and C. All right, when we start talking about these things, we're able to define elements in a certain way. Now, the next natural thing is that, okay, if I have defined a set as a collection of distinct elements, then the next word that we need to talk about, which was come up in chapter 1, which we kind of skipped, is called a subset. Okay? So what would a subset be? Well, I think you know, right? What would that be? A set in a set? Yeah, it's a set in a set. All right, so I like the way that you put that, right? Well, a subset are elements from the original set. Right? Elements from the original set. So as an example, right, a subset to my set S over here could be this. I could say a subset P is just B and C. See that? Or just C, right? Okay. So a subset is just elements from the original set, okay? And we have a symbol for subset. So in this case, right, I could say that P is a subset of S, and this is the way that we would write it. Okay? It's the letter, it looks like a C with a line underneath it, okay? So P is a subset of S. Why is P a subset of S? Because all of the elements that are in P are also in S. Do you see that? So we say P is a subset of S, right? Is S a subset of P? No, because not all of the elements that are in S are also in P. It's the other way around, right? Does that make sense? So this table right here, you guys are a subset of the class, right? You as an individual are a subset of the class, right? But it's not the other way around. The class is not a subset of you, right? So that's the one way to think of it, okay? So we have set, we have subset, and we have a way of describing it, okay? So let's talk about then for a moment, why do we even care about? Like, why does this even matter to us, all right? Well, let me give you an example of something, okay? Let's say that I'll give you a quote like T is a set of natural numbers. So natural numbers. What are the natural numbers again? 1, 2, 3, 4. Where does it end? It doesn't end, right? So 0 is not part of it, right? It's just positive integers. 1, 2, 3. Okay, so T is a set of natural numbers that are less than, we'll say 32. Okay? So T is a set of all natural numbers less than 32. So how many elements would be in this set? All right, so here, so I would say, well, okay, well, if I was going to write it out, it would be this, right? T would be, it'd be 1, and then what? 2, and then what? 3, and then what? 4. Okay. Do I really want to write all these out? Right? I could go dot, 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 all the way to like 31, and then 32, okay? Well, that's one way that I could write my set, my collection of distinct objects. Yeah, I will. So he asked, can't you just write 1 and then dash that dash to 32? No, there's a better way. We have a more sophisticated way of communicating using mathematics, and that's the inequality symbol, right? So we could say this. Okay, another way that we could say this is we could say, well, T is equal to this, right? T is equal to the set, any x that you want, provided, that line right there means provided that or such that, okay, we say x is a natural number, and we say x is less than or equal to 32. Okay? So what I have written down here, okay, combining the inequality statement with set builder notation is a much more sophisticated way than just writing out 1, 2, 3, 4, all the way up to number 32. Okay? Now I realize 32 is not very big, but I could easily have made that number 3,250, right? And I would not want to write all those elements out. We could just write this. So the way that you say this, okay, this is important. So we see these brackets so that we know that we're dealing with a set, okay? We say any x, this bar right here reads such that. You could say such that, or you could also say provided that. So it's basically like it's a contingent, right? You can pick an x as long as you pick an x that's a natural number that's less than 32. So anything that's inside here, this is the phrase that we're going to stay. So this phrase is always going to change, but everything else is going to stay the same. And then we close our set off in the end, okay? So I want you to be able to look at these symbols and to look at this language and understand what it says. It's basically reading another language, okay? So I'm saying, okay, T is the set. Any x that you want, provided you pick an x that is less than 32. I want that set. I'm calling that set T. Does that make sense to you so far? Okay. Okay, so negative 5x plus 7 is less than or equal to 17. So we're building on what we just did. It's an inequality statement. So we're going to solve the inequality. So we're going to subtract 7 from both sides. No big deal. So we're going to get negative 5x is less than or equal to, what, 10? Yeah. We're going to divide by negative 5. We're going to divide by negative 5. So we are going to now reverse the direction of the inequality sign. So x is going to be greater than or equal to negative 2. Okay. How do we write this in set builder notation? Well, we're going to say this. We're going to say any x such that x is greater than or equal to negative 2. So this right here is set builder notation, right? You can pick any x that you want such that x is greater than or equal to negative 2. So this is a shorthand way of writing a lot of possible answers. All right, a lot of possible answers. Okay, write this one in set builder notation. Try this one here. 9 minus 4x is greater than 21. So you got this all set x such that x is, I got less than negative 3. Is that what you guys got too? Okay, so all x such that x, oh, sorry, yeah, there you go, thank you. All x such that x is less than negative 3. Awesome. Yes, absolutely, very good. Okay, I'm going to define for you a set. A is going to be the set with elements 3, 4, and 5. Right now in your group, at your table, can you write down for me, please, every single possible subset you can find? Every single possible subset you can find right now. Go ahead and do it. Okay, I'm curious. Talk to me. Tell me all the subsets that you found. Will, give me your first one.
3.
Oh, yes. The subset by itself, 3, is a subset. Yes, give me another one.
4.
Yes, absolutely. 4. We're getting the easy ones out of that. I'm assuming you got 5 then based off of that, correct?
Yes.
Okay. Pallavi, give me another one. 3, 4. Okay, good. So 3, 4. And we have just had the conversation And we said that 3, 4 is the same subset as 4, 3. So the order in which the elements are arranged inside your set does not matter. So I could have had 4, 3 or 3, 4. It's the same thing. It's just a collection of objects, okay? Give me another one. 4, 5. Yep, that's one. Absolutely. Or 5, 4. However you write it down. Give me another one. 3, 5. Okay, so 3, 5. Did anybody find the others? 4, 3. No, I have that one. That one's 3, 3. No, I don't have 3, 3. Ah, okay, yes. Okay. Does everyone agree that I can't write any more? I can't write any more with just the elements themselves. Or can I? Yes. Okay, very good. Another one that people often forget is the set itself. 3, 4, and 5. That could be a subset. Every subset, or every set is a subset of itself. Weird, right? Right? You could just pick all everybody, right? If I'm going to pick a team, if I want to pick a team of 3, 4, and 5, I could just pick everybody. That's a collection. That's a subset, right? So that counts. And that's one that people often forget about. Now, what's the opposite of that? If I pick everybody, picking nobody, right? So that's the other one, okay? And we represent that with a 0 with a line through it. No. In this context, it means the null set or the empty set, okay? And those are the two that everybody always forgets about, okay? So let's talk about those. So this one, right, this is the subset of itself. That's okay to do. And this one over here, this is called the null set or the empty set. And the book, I think, uses both. Null set or the empty set. Empty set. Okay, so it could be both, right? The null set or the empty set. So we have a grand total of 1, 2, 3, 4, 5, 6, 7, and 8. I have those 8 subsets. Does that make sense to you guys? Okay, awesome. Feeling pretty good. Okay, so one way of looking at this, to introduce another concept here, right, is the use of a Venn diagram, all right? So if I say that a set has a certain number of elements, then we say we call that set the universal set. So as an example, right back over here, this would be the universal set. It's a set of everything that's in the universe of that set, so 3, 4, and 5. In the terms of our class, the universal set is every single one of you as an individual, right? You make up the set of students in my class, so you are members of the universal set. Does that make sense? Okay. So U is going to be our universal set. So then A is just, I'm going to call this set A. Okay, so set A is a subset of the universe, all right? So there is some leftover. There is the stuff that's on the outside of the circle, but still part of the universe. And we have a name for that, and that's called a complement, all right? So this is called the complement. Yeah, you're very welcome. The complement of set A. So the way that we describe a complement of set A, and it's written as A with a little tiny little hash mark, A caret or A prime. The way that we describe the A complement is everything that's still in the universe, but not in set A. You see that? Everything's in the universe, but not in set A. So let me give you an example within the same box to illustrate the point here, okay? So let's say that I'm going to call my universal set is going to have elements 1, 2, 3, 4, and 5, okay? I'm going to call set A is going to have elements 1, 4, and 5. So therefore, A is a subset of the universe. Does that make sense so far? Okay. Intuitively then, can you guys tell me what would the complement to A be? It would be everything that's in the universe but not in set A. So what elements would that be? It'd be 2 and 3. Isn't that kind of fun, the way that we describe it? I mean, it seems basic, but what we're doing is we're talking about a way to actually describe every single part in terms of the universe, a set, or its complement, right? So we're learning a lot of vocab in this as well, okay? So we'll do one more example together. Okay, tell me all the pieces of the chess game. Oh, you got the king. There's a horsey. Yeah, there's a king. Okay. There's a bishop, yeah. There's the knight. Okay. There's the rook. right? There's the rook, and then there's the pawn. Okay, did I get them all? I have the king, I have the queen, I have the bishop, I have knights, I have rooks, and I have pawns. Okay? So the horsey is the knight. The horsey is the knight. Okay, all right, so check it out. This is my universal set. I'm defining my universal set to be all the pieces or all the players of a chess game. You guys with me so far? Okay, this is why this part of math is cool, because we're not talking about numbers. We're talking about a collection of distinct elements, right? All right, so I'm going to call A, all right? A is going to be all the pieces that can move side to side. Side to side. Does anyone know that?
Yes, that would be rook.
Which ones can move side to side? Yes, the rook can move side to side. The king and the queen. Very good, okay? So A is all the pieces that can move side to side. So what would a complement be?
So the complement would be the knight,
The knight, yep.
bishop,
The bishop, yep.
and the pawn.
And the pawn. Very good. Okay?